Hello everyone, and welcome to the linked list reversal solution lecture. Again, your problem statement was to write a function to reverse a linked list in place. The function should take the head of the list as input and then return the new head of the list. You were given this example of a linked list node class, and now let's go over the solution. Since we want to do this in place, we want to make the function operate in constant space, meaning we don't create a new list and add elements to it, or set up some other nodes. We have to do it in place. So we will simply use the current nodes. Time-wise, we can actually perform this reversal linearly, in linear time big O(n). We can reverse the list by changing the next pointer of each node. Each node's next pointer should point to the previous node. In one pass from head to tail of our input list, we will point each node's next pointer to the previous element. Make sure to copy the current.nextNode attribute into the next node before setting the current next node to the previous. So hopefully that sounds a little familiar from the lectures as far as how to insert new nodes and the order to do it in. In this case, we're not inserting anything new, we're just reversing the linked list in place. Let's go ahead and see this idea and strategy implemented out in code. I'm going to go ahead and hop over to a Jupyter Notebook. Alright, and let's go ahead and get started. First thing I'm going to do is start by writing out my function. So I'm going to say def, just call it reverse, and it takes in that head node. What I'm going to do is set up three variables: current, previous, and next. And these just stand for the nodes I'm at. So current, we'll start that off as the head node. Previous will just be none for now. Whoops. And we'll say next node is also equal to none right now. Now we're going to say while current. And this while loop will essentially let us know until we have gone through the end of the list. And then what we're going to do is make sure to copy the current node's next node to a variable next node before overriding as the previous node for reversal. And what I mean by that is doing this. I'll set next node variable equal to the current next underscore, actually next node in this case. Let me go ahead and paste in. We'll say pass here for now, just so I can paste in the cell code here. Copy and paste it just so we remember what the actual attributes are. We have value and next node. Alright, so just continuing on. So we set next node equal to current.nextNode. The reason I stopped for a bit is because in some of the node implementations we did, we had an underscore there. That's pretty much up to you on how you implement it. But in this case, for the solution notebook, we didn't have an underscore there. So I'll just say next node variable equals the current node's next node. So I want to make sure to copy the current node's next node to a variable next node before overriding as the previous node for reversal. Then I'm going to reverse the pointer to the next node. I'm going to say current dot next node is equal to previous. Then I'm going to go one forward in the list, which just means previous is now equal to current, and current is equal to that next node. After all of that, I just return previous. Let's go ahead and run this and test our solution. I'll zoom out a bit. And as I noted in the previous lecture, we can just copy and paste what the cell says there. So we create a list of 4 nodes, set up that order A, B, C, D with values 1, 2, 3, 4. We go ahead and print those values. I'm just copying and pasting from that solution notebook. And then we get 2, 3, 4. Let's go ahead and reverse this in place. Okay, we reversed it. It returned. And now let's print D, C, B. And we get 3, 2, 1. Okay, so now we can see that each of the values points to the actual previous value. Given that we're calling the next node of D, it's actually 3 now, C next node is pointing to 2, B is now pointing to 1, etc. Instead of the other way around, where B next node was pointing to 3. In this case, we don't do D in this first one or A in this first one because they're both pointing to none. All right, that's it for this problem. Let's just walk through the main code one more time, this reverse function. All we have to do is set current, previous, and next node. And in this solution, the key thing to note is that you have to go through the entire list until the end of the list, and you want to make sure to copy the current node's next node before overwriting as the previous node for reversal. That's basically the trick to this. So making sure to copy that current next node before overwriting the current next node as the previous. If you mix up this ordering, you won't have anything else to reference, and the algorithm won't make sense anymore. After that, you just set previous equal to current, and then current equal to that next node. Okay, go ahead and check it out on your own. Make sure you understand it. But that's really all there is to it as far as reversing a linked list in place. This is a pretty common interview question, so make sure you fully understand it. Thanks everyone, and I'll see you at the next lecture.